so let's review function notation. Now, I'm not going to read all the words here, but you can do that. Since function notation is another way of writing y equals, instead of y equals the equation, we have f of x equals. We use that because the different letters, we can do f of x, g of x, k of x, p of x, those allow us to differentiate between different functions. So for example, we're given a function here, f of x equals negative 7x plus 3. Now, when I look at that function, I'm asked to evaluate f of negative 2. Now that negative 2 is inside the parentheses. Notice here when I look at f of x, inside the parentheses is the variable x. So that means the negative 2 is an x value. So when you evaluate this function, I'm going to take that negative 2 and put it in where the x would be in the equation. So you'd have negative 7 times negative 2 instead of x plus 3. Negative 7 times negative 2 is positive 14. Oh, that's a typo. Positive 14 plus 3 is 17. So your answer here is 17. Now, if you are asked to find a value the other way, where it says f of x equals 24. Well, notice the 24 is not inside the parentheses. It is set equal to the function. Remember, f of x is the same thing as y, so that by the transitive property means that y is equal to 24. That 24 is not in the parentheses, so you cannot put it in for x. It's saying find the value of x. So what we'll do is set that y equal to the equation and then solve it for x. So you subtract 3 and get 21, divide by negative 7, your solution is negative 3. I'll do a couple more examples down at the bottom, but I wanted to talk you through the math that was there, even though it was a little bit wrong. Alright, so let's try some practice. Now we're going to just be careful. We're given 4 different functions. We want to make sure that we match up the function with the correct, like the function notation with the correct function. Firstly, I have f of 1.5. F here, this letter, means I'm going to use the function of f. 1.5 is in the parentheses, so it is an x value. I'm going to put 1.5 in where x is. So 16 times 1.5 minus 5. Okay, well, if you don't know what 16 times 1.5 is, go ahead and use your calculator. You'll get 24. So we have 24 minus 5, which equals 19. 19 is the output that goes with the input of 1.5. Next, I have j of negative 3. So I'm using the function here, j. Negative 3 is in the parentheses, so I'm going to put that negative 3 in for x. So I'll have the square root of, instead of x, negative 3 plus 7. Well, negative 3 plus 7, when I simplify, is 4, and the square root of 4 is 2. All right, lastly, find x when f of x is negative 85. So I'm going back to this f of x, the graph in pink, or the equation in pink over here. The negative 85 is not in parentheses, so it is an output or y value. So what you do is you're going to take the function and set it equal to the output. Okay. Now, I'm going to solve for x by adding 5 to both sides. I'll get 16x equals negative 80, and then divide by 16. If you need, go ahead and use your calculator here. Negative 80 divided by 16, and you get negative 5 as your answer. All right, let's try a couple more. If you want, go ahead and pause the video and try the next 3 on your own, and then come back and see if you're right. All right, k of negative 1. So let's see. K here is using the second function. K of negative 1. Now, negative 1 is in the parentheses, so it's an x value. So I'll take 3. Now, this time, I want to make sure I put negative 1 in parentheses, especially because I'm going to be squaring it, plus the negative 1. All right, negative 1, the quantity squared, is positive 1. So this is really 3 times 1, and then plus a negative is just a minus 1. 3 times 1 is 3, minus 1 equals 2. All right, E. Find x when g of x equals 31. So g of x is down here, and 31 is set equal to the equation. It's not in the parentheses, so it's y value. So I'm going to set 31 equal to the original function, and then solve for x. I'll start by subtracting, and then notice there's a negative 1 hidden there in front of the x. So I have to divide by negative 1, and I'll get 29 is equal to my input value that I was looking for. Lastly, k of x again, back to the function that I circled in black. K of 10. 10 is in the parentheses, so it's an x value. So I'll replace x here with 10. 10 squared plus 10 on the end. All right, 10 squared is 100. So I have 3 times 100 plus 10. That would be 300 plus 10, which is 310. And there's your answer. Hopefully you remember and you're decent and good at function notation from equations. Part 3 here, is recalling function notation from other formats. Okay, tables, graphs, equations, mapping diagrams. Or we already did equations, but tables, maps, mapping diagrams, and graphs. All right, P of 0. P of x is the graph right here. When I have 0 in the parentheses, that's an x value. I go to where x is 0, and you count down on the graph. 1, 2, 3 gives me an output of -3 for that x value. Think about x, and then the -3 is the y. That ordered pair right there that I found is 0, -3, x and y. All right, n of 12. N is the table. 12 is an input value in x, so I look in the x column for 12, and I find that its output is 12. All right, find x when b of x equals 6. Now, b of x is the mapping diagram right here. The inputs are on the left, the outputs are on the right. You can see how the arrows flow. 6 is not in the parentheses. It's an answer. It's a y value or an output. So I find the output of 6, and I go backwards to find its input of 3. All right, next, find x when n of x equals -2. So n of x is the table. -2 is an output value. So I find my output value is -2. I go backwards to find the input value of 7. Find x when p of x equals 3. Well, again, that 3 is an output value. It's set equal. So this time, I'm going to go to the y value of 3. Find where I have a y value on my graph right here, and go down to the x's. That would be at -6. So the x value of -6 gives me an output value of 3. And finally, b of 1. 1 is an input value, so I start at 1. I follow the arrow to get the output value of 2. All right, those should be really easy for you. The next part compares functions using different features of graphs that you've learned about briefly in the past. So let's see. For the first one, which of the following functions has the largest maximum value? So you're probably going to need your graphing calculator for this. What I would do is graph this. We've used some calculator skills as well. So let's start by graphing -x² plus 6x minus 4. And I'm going to look at the picture. And I can see the maximum here, but I don't know what the maximum value is. So I'm going to trace it. Second trace, choose maximum, which is number 4. And we just remember, need to get the cursor up to the left of that maximum, to the right. And we get a maximum here at 3, 5. Now the maximum value is looking for the y value, which here would be 5. That's the highest value of the graph. So I'm just going to make a note for myself here that the maximum value is y equals 5, or just 5. You don't even need the y equals. It's just 5. All right, t of x. Let's graph this one. -x², x plus 3, x minus 2. Okay, so -x², parentheses, x plus 3, x minus 2. And again, hit graph. You can't see the maximum here. It's a cool looking graph. It's actually a quartic function. Looks different than our parent function, but it's a quartic function. Let's make the window a little higher in the y. So why don't we make the y max, let's try 20, and I'm going to go by 2s. You don't have to change the scale, but I'm going to here, just to make it a little easier. There, I can see the maximum, so now let's trace it. Now, I'm looking for the very highest point, which will be that peak on the left. So I bring that cursor up around that highest peak, and I get an output value of 16.3. That's the maximum highest value on the graph. So 16.3. And then finally, n of x, negative 3x squared minus 6. Right, this one's down below. I can reset the graph. Remember, I hit zoom 6. And when I trace it, I know it's going to be a negative, so it won't be the winner, but at least we can practice finding the maximum here. The maximum is at negative 6. All right, so the answer, the largest maximum, would be t of x. Next one, rate of change. Remember, rate of change is the same thing as slope. We're going to find the slopes on the interval from negative 3 to 4 for each of these functions, and then decide which slope is the steepest. All right, rate of change for the graph. So negative 3, I'm going to put a dot on my graph. We can use the slope formula in a minute. I'm going to do rise over run for the graph. So I put a dot on the graph at x equals negative 3, and a dot on the graph at x equals 4. Here I'm just going to find the rise over run between those 2 points. So here I go down 3, run over 1, 2, 3, 4, 5, 6, 7. So the rate of change here is negative 3 over 7 for a of x. For h of x, I can find the rate of change for negative 3x plus 5. And actually, I'm going to give you a shortcut. The rate of change for a linear function is equal to the slope. Right? It is the same as the slope, which is what rate of change is. Just sometimes rate of change is taken over curved graphs. So shortcut there. Lastly, rate of change for x squared minus x minus 6. Let's make a table on our calculator, find some ordered pairs, and use the slope formula. So we'll do x squared minus x minus 6. So here's the picture, so you see it. Let's go to the table. I want to find the rate of change from x equals negative 3. So negative 3, 6 is one ordered pair we're going to use. And then to 4. And 4, 6 is the ordered pair. To find the rate of change, I've used the slope formula. So I'll take one of my y's here. I'll do 6 minus the other 6 over the x of 4 minus negative 3. 6 minus 6 is 0 over 7, and 0 divided by anything is 0. So actually, the steepest rate of change is the largest absolute value of the slope. That would be h of x. H of x, if I graphed all of them, would be steepest on that interval. All right, last one. Of the functions, which one has the smallest product of their x-intercepts? Product means you're going to multiply. So here you just got to think a little bit. The x-intercepts on this graph, we have an x-intercept at negative 5 and an x-intercept at 0. Negative 5 times 0 equals 0. Okay, that's the product of the x-intercepts for A. For B, we're going to have to graph it first. 3x squared plus 19x plus 6. So let's see, 3x squared plus 19x plus 6. So we're going to trace the x-intercepts, or the zeros. Okay, so we'll trace here. We'll do this first one. We're on the left. That root's at negative 0.3 repeating, which is negative 1/3. So I will root at negative 1/3. And then my next root, let's see. To bring the cursor all the way over this other side. It's getting there. All right, left bound is above, and they're below. And that root is at negative 6. So let's see. I have x equals negative 6. So to find the product, I do negative 1/3 times negative 6, and that equals positive 2. Right? So that's the product of those x intercepts. Last graph, x squared plus 5x plus 4. And I think we can see here that that's at 1, negative 1, and negative 4. Let's double check on the table. Yep, negative 1 and negative 4 both have y's of 0. So, and negative 1 times negative 4 is positive 4. So the graph that has the smallest product is W of x, because that has a product of 6. Alright, so the next page, I didn't put it on here, is review of matching parent functions, one-to-one, and even odd or neither functions. Try that. If you need any more help, ask your teacher.